So on these problems, we are looking at finding the vertical, horizontal, and slant asymptotes, or state that they do not exist. So on our first problem, we are looking at f of x equals x squared plus 4x minus 4 divided by x minus 4. So on our vertical asymptote, we are basically looking for the domain. It's the same thing that we did on domain problems. I'm going to write VA for vertical asymptote, so I don't have to keep writing the big words, and all you're going to do is take the denominator and set it equal to 0. That's all you do. Add the 4 over, and you get x equal to 4. That is your vertical asymptote right here. Okay. For our horizontal asymptote, I'm going to write HA. The horizontal asymptote, we are looking at taking the first term and dividing it by the second term. Basically what you want to do is look at taking and matching our degrees. So if I look at the top and I look at the bottom, we're looking at the degree that's highest is 2. So I'm going to put x squared here and x squared here. Now how many x squareds do I have in the top? Well, here I have 1x squared, so it's good right there. How many do I have in the bottom? I have 0x squared. Well, x squared we're going to cancel, and what's 1 divided by 0? Oh, that's undefined. We can't do that, right? So if this is undefined, then that means we have none. Okay? If we are looking at our synthetic asymptote, then we are going to do synthetic division. So slant asymptote, sorry. Slant asymptote, we look to see that the top is bigger by 1 and exactly 1 than the bottom. And in this case, we are talking about the degree. Okay, so our top degree is 2. Our bottom degree is 1. So 2 minus 1 is 1. That means we could have a slant asymptote. So we're going to do synthetic division. This is where we look at our x minus c, and this is in the minus. That's for our part that goes in here, x minus c. Needed in that format. Because it already is, we're just going to pull the positive 4 out. You don't bring negative 4, you bring positive 4 because you're looking for the c. So pulling our exponents at the top, or I mean our coefficients at the top, we've got 1, 4, and negative 4. So bring down our 1. 1 times 4 is 4. 4 plus 4 is 8. 8 times 4 is 32. Negative 4 plus 32 will get us 28. Now we can rewrite this as an equation. So x plus 8 plus, this would be 28 over x minus 4. That would be our remainder. However, we're only looking for this part here. So our slant asymptote is y equals x plus 8. So now you have all three of your asymptotes. On our next problem, we have g of x is equal to x plus 4 divided by x squared minus 1. So again, we're looking for our three types of asymptotes. So on the vertical asymptote, we're again setting our denominator equal to 0. So x squared minus 1 is equal to 0. I'm going to add 1 to both sides. So x squared equals 1. Taking the square root of both sides, I get x is equal to plus or minus that square root of 1. So x equals plus or minus 1. Remember, you always have to add the plus or minus on there whenever you introduce a radical into an equation. These would be the things that would cause us to divide by 0, which we don't want, and that's why they will be an asymptote there. When we're looking at our horizontal asymptote, again, we are looking to match our degree. So our highest degree is x squared again. So x squared over x squared. How many x squareds do we have on the top? Well, we have 0 x squareds. On the bottom, we have 1. So you can write the 1 or not. Last time I did, and I'm showing you different ways that you can approach it. So the x squareds will cancel. Well, what's 0 divided by 1? Well, that's 0. So our horizontal asymptote will be y equal to 0. Now, if you have a horizontal asymptote, you're not going to have a slant asymptote. So at this point, we know there will not be a slant asymptote. The other way that we know that we're not going to have one, that there will be none, is remember we talked about the top degree has to be bigger by 1 than the bottom degree. Well, our top degree is smaller than our bottom degree. So that tells us that we are not going to have a slant asymptote because it will not be, there is a difference of 1, but the top has to be bigger. So there is none. The next one that we are looking at is going to be this one. And here we're going to sketch the graph of the rational function, including all asymptotes. So we're going to find our asymptotes first, and then we'll proceed from there. So our vertical asymptote is going to take our denominator, x squared minus 36, set it equal to 0, and we'll add our 36 over. So we'll get x squared is equal to 36. Taking the square root of both sides, we get x equal to plus or minus the square root of 36, so x equals plus or minus 6. On our horizontal asymptote, again, we are looking at matching our degree. So our bottom degree is x squared, and it's bigger than what's on the top. So we have 0x squared on the top, and we have 1x squared again on the bottom. So this will get us 0 divided by 1, which is 0. So y equals 0 is our asymptote. Now these are lines, so don't put them as points because they are actually lines. So if we have a horizontal one, we do know that we're not going to have any slant asymptote. But again, if we look at the top degree, is not bigger than the bottom degree, so that also tells us that we will not have one. Now one of the things you can look at these with our asymptotes is it's always about zeros. So with the vertical asymptote, you set the denominator equal to 0. And on the horizontal asymptote, you are 0 filling what either the top or the bottom. But if you actually had x squareds on both, you would actually be using the constants that set next to the x squareds. But it's about zeros. If you can remember that, it kind of helps you figure out what's happening there. All right, so now that we have our asymptotes, the next thing that help us graph our function will be our intercepts. So we're going to do the x-intercept, where we set y equal to 0. Remember, f of x is the same thing as y, so 0 equals 4x divided by x squared minus 36. Well, I want to get rid of my fraction, so I'm going to multiply both sides by the denominator. So x squared minus 36 times 0 is just 0. Here it will cancel, and that gets us 4x. Divide by 4. 0 divided by 4 is 0, so 0 equals x. So here our x-intercept will be 0, 0. Now our y-intercept, we set x equal to 0. So y will equal 4 times 0 divided by 0 minus 36. Well, 4 times 0 is 0. 0 minus 36 will be negative 36, and that is going to equal 0. So here we have y is equal to 0, which is going to give us the point of 0, 0. So we have a few things on our graph that we now know, and we need to do a little bit more. We need to figure out what happens at each of our points. So I'm going to go ahead and start drawing our graph. This is our x, this is our y. Remember, try and balance your hash marks. But remember, we're always just sketching. Alright, so the first thing I'm going to do is put on my asymptotes. So here I have x equal to plus or minus 6. These are not points, so I'm going to do one at 6 and negative 6. So 1, 2, 3, 4, 5, 6. And these are dotted. They don't actually equal these points, but on our graph, This is where our graph won't actually touch the points here. And then our horizontal asymptote is at y equal to 0. Now on a horizontal asymptote, we can actually cross them. Verticals we do not. And then we don't have a slant asymptote. Our x-intercept is at the origin, and so is our y-intercept. Well, we don't know what's happening with the rest of our graph here. We don't know what else is happening. So we need to figure that out by doing some test points. We need to know if our graph is here, is it up here, is it at the top, is it at the bottom, is it here, or is it here? What's happening here? So the best way to do that is figure out what values we are near and put some points on either side. So I'm looking at that I have a point that I need to figure out. The one that's closest to your asymptotes, your vertical asymptotes, will help you. So on this one here, I have -6, so I'm going to go one more and do -7. So I'm going to create a chart here, and I'm just going to plug in some points to figure out where my graph is happening. So I've got my -6 there, I've got something happening here at the 0, and I've got something else here at the 6. So the other side of -6 is -7. Between 0 and -6, I need to pick a number. I like to choose the smaller numbers because they're easier, so I'm going to pick -1. And on this side, I'm going to pick 1 between 0 and 6. And then from 6 after, again, I'm going to pick the closest number, which is 7. You can pick 10, you can pick any number you want. You just need to, I like to pick smaller numbers. So now I'm going to plug in these values into my original function to figure what the value is. So I'm going to have 4 times -7, because that's where my x is, divided by -7 squared minus 36. So 4 times -7 will get me -28. And -7 squared, remember that's going to get you 49. It's going to be positive because squaring a negative. And then minus 36. So -28 divided by 49 minus 36 will be 13. This is going to be approximately -2 and 2/13. So divide 13 into 28 and that's what you'll get. So we have an idea where that's going to be. We'll plot these all at one time. So we're going to plug in our -1. So we got 4 times -1 because we're going back into our original equation up here, divided by -1 squared minus 36. So -4 over 1 minus 36. So that will get us -4 over -35, which will equal +4 over 35. Plugging in our 1, we'll get 4 times 1 over 1 squared minus 36. So that's 4 over 1 minus 36, which will be 4 over -35. And then our last one, we will have 4 times 7 divided by 7 squared minus 36 is 28 over 49 minus 36, which is 28 over 13, which will be a +2 and 2/13. And we're just kind of getting an idea of what that number is so we can graph it. All right, so we'll start at the top one. So we have -7 and -2/13. So it's going to be down 2 and a little bit further than 2. It just tells us generally this is where our graph is going to be. On this one up here, we are looking at -1, and it's a +4/35, so it's going to be something close to the axis. It doesn't matter. Remember, we're sketching. And 1 and a -4/35 will be about right in there. And then on our 7, we are looking at going up to +2. So up 2 and a little bit more. Remember, it's just a sketch. All right, so this graph here, we can see is coming down and curving like this. And it's going to get close to, but never cross our asymptote. The other parts are going to, if we plotted some more, we'd find that it would come around like this, and that needs to kind of go close to our asymptotes. Remember, I'm not an artist, I am a mathematician, so they're not going to be perfect graphs. And then here we're going to come up close to here, and we're going to curve around this way to our horizontal asymptote. You could plot more points to figure that out, but when we're trying to just sketch a graph and you're limited on your time on your test, it's going to be difficult to keep plotting a whole bunch of points because it takes time. But that gives us a general idea of what's happening with our graph.